So you can see here that in the original configuration with using the factory torsion spring, we are fully extended, and the lowest we can go is 6.75 inches. That's with the factory torsion spring. Now it would be, if we didn't have our ball nut mounted on the top as we do here, it would be another ½ inch. So it would be about 7¼ inches of travel down that we would achieve with the factory torsion spring. Now here are the components that I came up with for my air spring conversion. This bracket will just be mounted on a bolt where it mounts to the bench, and then this bracket will be mounted using this hole, will be mounted in the same location as the mount is for the torsion spring bracket. Now I came up with this configuration because there will be times when I need to go as far as possible toward the work table, and there'll be times when I'm going to be doing milling that I will have to go as high as possible. As you can see, there's a slot in the back, so this makes this adjustable, and I think this gives me the best of both worlds. Unfortunately, when you're converting to an air spring, they only come in certain sizes. So when compressed, this particular spring is about 9 5/8 inches, which will not get you all the way down to the table. You need something in the 6½ inch range. But if you use if you use an air spring that is 6½ inches, then you don't get the full extension that you need, which is around 15 3/4 inches is what you need to get the full extension of the Z height in my Z-mount configuration. So this spring is, like I said, about 9 5/8 inch when it's compressed, and around 16 inch when it's fully extended. And this gives me the best of both worlds. So let's see how it's mounted. Okay, so we have the air spring bracket mounted, and as you can see, there's the bottom mount. Just mounts on that rear left-hand mounting bolt, and then you can leave the original spring, torsion spring, for now, and as you can see, we have mounted the bracket, the top bracket, straight to this arm, that went to the original torsion spring, used the same bolt, and I have it set in the slot at its lowest position. In its lowest position, our top height, we lose approximately 1/4 of an inch of travel in the up direction. And then in the down direction, let's see, in the up direction, let's measure that from the bottom of the spindle. Put the ruler this way. From the bottom of the spindle to the table is approximately about 9 5/8. From the bottom of the spindle to the top of the table is about 9 5/8. As you can see, it doesn't get in the way of anything. It's off to the side. That's fully compressed. And at fully compressed, we're about 6.5 inches of travel. And as you can see, we are about the same as the factory. We are about 3 inches from the bottom of the spindle. So you don't have as much upward travel, but you can go down to its lowest point exactly the way the factory is set, about 3 inches up from the table to the bottom of the spindle. Might be a little easier to see if we go that direction, but it's about 3 inches. Now, if we adjust our mounting bolt and just move it up to here, we can literally get all the way down to the bottom of the table. We only need around 3 inches, so we can get another 2.5 inches of travel just by simply sliding this up. Now we will lose our upward travel, but we can get all the way down to the bottom of the table. So let me see if I can loosen it up and adjust it and get there. It's just, you don't have to take it off to adjust it. You can just simply loosen it up. Simply loosen it up and loosen it up some more. Simply loosen it up, put it at the top. Okay, and now we've picked up another 2.5 inches of downward travel. Okay, so now you can see with my end mill in the holder, I can get all the way down to the bottom of the table, and I can't go any lower because it's actually real close to my vise, and so it won't clear the vise. So I can't show you how far it'll go down, but it'll actually go all the way down. The bottom of the end mill holder will actually go all the way down to the table. So if you had just a normal collet in there, then a regular collet comes up to the bottom of the spindle. So you would still be able to get your bit all the way down to the top of the table. As you can see, there's still an extra 1 inch of travel, maybe a 1 1/4 inch of travel with the adjustment all the way to the top. as far as your upward travel, of course you're going to lose some of your upward travel. So as far as your upward travel, as you can see, we've lost about the same amount as we went down, around 3 inches or so. But in the end, around around 2 1/4 inches. So around 2 1/4 inches of height that we lost. Let me see if I can get it over the vise. As you can see, we still got plenty of clearance. And so that's with the bracket in the upwardmost position. Now, if you remove the torsion spring, another thing about this is, if you move the torsion spring, you can actually turn this like so, and you can even get more travel. You can adjust this bolt, just loosen this up and tighten it back up, and have it here or here, and you can get even more downward travel, as much as you need. This bracket here can just be flipped to the back side. If it's flipped turn to the back side, then you move your pivot point over to here, and you can get your column. Your air spring can be over here. But I think for most purposes, this is my y-axis is back as far as it'll go, and I've got a good couple inches of clearance here. And I really don't think that for the type of machining I'm going to do, I've got more travel with this configuration than I had with the stock torsion bar. So I'm completely happy with that. And the whole modification didn't cost that much, just my time to make the brackets and purchase an air spring. So if you guys are interested in the how-tos and where to get the springs, or if you're interested in just a complete bolt-up kit, let me know, and I can make one up for you. The nice thing about this is it will work on a manual mill just as easily as it works on a CNC. So this conversion is universal. You don't have anything hanging above in the way, so you can put it in an enclosure. I think converting to an air spring is the right idea, but putting it above just didn't work out for me in my particular application, because I wanted to put my mill in an enclosure, and I just didn't have the headroom. One more note, with the air spring in the stock standard position, with it mounted all the way down at the bottom of the slot, fully compressed, as you can see, I'm well below my tool vise, which is what I do most of my machining off of anyways. So this is perfect for my particular application. I hope this video helps someone else who's interested in putting an air spring in. Very simple to make. It takes about 5 minutes to bolt it up. You just simply bolt this to the stock position and bolt the bottom bracket to your mount. Works really well. I'm very pleased with it, and it definitely assists in moving the head. Definitely assist in lifting the head up. As you can see, we're at the top of the height, so we've lost a little there. But you're not going to get full extension and all the way travel with an air spring. They just don't make one that is the correct size. So for my particular application, with using the ball nut mounted in this fashion, this is the best air shock that I could come up with. And the bracket just makes it even more versatile, because I can just get lower with the adjustments. So thanks for watching the video, and got any comments, please post them. If you got any questions, please post them, and I'll try to answer them and help you out as much as I can.